Hey gang, today we're going to continue factoring polynomials completely. So again, we want to start by seeing if there's a common monomial factor that we can take out. We're going to do the odds together. And here in this first one, we can take out y since both terms have a y. When I take out y, I'm left with y times 3y to make 3y squared and y times 10 to make 10y. Both of those factors don't have any other common factors, so that's really as far as we can go. Sometimes it's really just that simple, so don't overthink it. In that case, only a monomial factor can be factored out. All right, number 3, x squared minus 16h squared. Well, in this case, I don't have a common monomial factor, but I notice that both terms are perfect squares, and there's a minus sign. So that means this is a difference of two perfect squares. So I can do x minus 4h times x plus 4h. And again, neither of those can be factored further, so that's as far as we can go. We've factored it completely. Number 5. Here, we're going to factor by grouping because neither of those three terms have a common monomial factor. We know that 14 has factors of -2 and -7, which add to -9. So we can do y squared minus 2y minus 7y plus 14. Here, we can factor out y. We get y times y minus 2. And we want this to be negative, so we're going to take out -7 and we get y minus 2 again. So my common binomial factor is y minus 2, and my second is y minus 7. And neither of those two factors have a common factor, so we've factored completely. Okay, number 7. Now I have 2x squared plus 12bx minus 32b squared. All right, so I'm trying to fool you here. It kind of looks like there should be a variable that's in common, but we have 2 with x's and 2 with b's, so there's no variable in common. But I do have 2, 12, and 32, which are all even numbers, so we can factor out a 2. If I factor out 2, I get x squared plus 6bx minus 16b squared. I love when my pen changes colors on me for no reason. Okay, so now I want to factor by grouping. So 1 times -16 is -16, and I need my factors of -16 that have a sum of +6. So what couldn't be 4 and 4, possibly 2 and 8. I want +6, so it should be 8 and -2. That makes sense. So now we factor by grouping. We get 2 times x squared plus 8bx minus 2bx, because those replace that 6bx, minus 16b squared. Then we can group and factor further. So from this group, I can factor out x, and that leaves me with x plus 8b. And from here, I can factor out negative 2b, and that leaves me with x plus 8b again, because 8 times 2 is 16, and b times b is b squared. So my x plus 8b is my common factor. I got to bring down this 2 though. So it's times x plus 8b, and then I have left over x minus 2b. And that is then factored completely because none of those three separate binomials or monomials can be factored further. All right, so that one was a little bit tricky. Let's try number 9. Okay, so for number 9, now I've got 3 terms, but those 3 terms do not have a common monomial factor. So we're going to start by factoring by grouping. 60 times -6 is -360. I don't know the factors of that off my top of my head that would make a sum of +37. So I'm going to go to my calculator and type in -360 divided by x. And I want to look for factors that could possibly have a sum of +37. I notice here 8 and -45. If I did 8 minus 45, I would get -37. So 45 minus 8 should be +37. So 45 and -8 are my factors. Now I can start to group. So I've got 60a squared plus 45a minus 8a minus 6. Group and group. 60 and 45 have 15 in common, and I can take out a. 15 times 4 is 60, so it's 4a, and 15 times 3 is 45, so it's times 3. Then minus, because I want a plus sign here, I need to change this to a minus on the outside to get that minus on the inside, or plus sign in the middle. So I take out this negative, and I would get 2 taken out as well, because 8 and 6 have a factor of 2. And that as well leaves me with 4a plus 3. So my common binomial factor is 4a plus 3. And then my second factor is 15a minus 2. And neither of those factors are factorable further. Okay, they're all prime, so that is factored completely. All right, 11. If 25x squared minus 80x plus 64 represents the area of a square, find the binomial that represents the length of the side of the square. Again, it's asking for a square, so that means that this should be a perfect square trinomial. I should be able to get a binomial that is the same for both sides of the square. So we're going to factor by grouping here because 25, 80, and 64 do not have any common factors. So we start by doing 25 times 64. That gives us 1600, which is a perfect square. And we know the square root of 1600 is 40, and 40 plus 40 makes 80. So we could make it negative 40 and negative 40 to get negative 80. So now we can start grouping 25x squared minus 40x minus 40x, replacing that 80x plus 64. Group and group. Factor out of 25 and 45 and x leaves us with 5x, because 5 times 5 is 25, minus 8, because 5 times 8 is 40. And then over here, factor out negative. 40 and 64 have 8 in common. 8 times 5 is 40, with the x needed, and 8 times 8 is 64. And I need it to be negative to make that positive there. So our common binomial is 5x minus 8, and we're left with 5x minus 8 again, proving that this is a perfect square trinomial because I could rewrite it as 5x minus 8 all squared. So the side of the square is 5x minus 8. All right, so that was a lot of work. You are now going to complete the evens on your own, and I'll be around to make sure you're on the right track.